Hey, hello guys, this is Shubhabrata and welcome back to our channel circuiTician. This is the third part of Arduino and embedded system tutorial for beginners. In the last part, we have done the digital output of Arduino and what functions to use for them. But today, in this part, we are going to learn about digital and analog input-output of Arduino and which function we will use for them and what is the debounce effect. And later on we will also learn about serial monitor. So don't skip the video, watch till the end. Let's get started. As we are done with the digital output of Arduino, so today we will start with the analog output. But Arduino doesn't have a digital to analog converter which is required to generate analog signals. But Arduino have PWM block which can generate PWM signals and by which we can achieve some of the functionalities of analog signals like controlling brightness of a LED or controlling speed of a motor. In Arduino Uno, Arduino Nano and Arduino Pro Mini, which consist at Mega 328P microcontroller, we have total 6 number of PWM channels or PWM output which are in the pin number 3, 5, 6 and pin number 9, 10, 11. So to do this experiment and for check out the PWM signals of Arduino, we will require a Arduino, a LED, a 220 ohm resistor and obviously a breadboard and some jumper cables. So here we have this 220 ohm resistor and this LED. Now we will connect this LED and resistor to the breadboard. So first I will connect the resistor to the D3 pin. I've connected and one leg in this power rail. So now I will connect the positive of the LED, with the leg is bigger, positive leg with the resistor and the negative leg directly to the Arduino ground. So we have completed our circuit. Now I will upload the program to this Arduino. This is the code of analog output. First we have to know what we are doing in this code. In this code we are increasing and decreasing the LED brightness. So we take total time of 10 seconds for that. So first 5 seconds is for increasing the brightness and the second 5 seconds for the decreasing the brightness. So first here we take a variable and the variable type is constant integer and the variable name is analog pin. As we have connected the LED to the pin number 3, so we are storing the pin number 3 in this analog pin variable. Now in the void setup we have to declare the pin mode. So in our case it will be output because we are performing the experiment of analog output. So we have write down the pin mode. In the void loop there is two for loop. The first for loop is for increasing the brightness of the LED and the second for loop is for decreasing the brightness of the LED. In the first for loop, as we are increasing the brightness, so here we increasing the value of I from 0 to 255. It means total 256. As Arduino can give output of 8-bit resolution, analog output of 8-bit resolution. So if we calculate 2 to the power 8, it will be 256. So we take the value from 0 to 255. And for giving analog output, we have the function analog write and in the parentheses we have two arguments. The first is the pin name or pin number and the second is the amount of brightness. That means it should be in between from 0 to 255 and after increasing each percentage or each number which is in between 0 to 255, we are giving a delay of 20 milliseconds. So it will take a total 5 seconds to increase the brightness because if we calculate 20 milliseconds into 256 steps, it will be near about 5 seconds or 5000 milliseconds. And this thing is same for the second for loop, but here we are decreasing the brightness. So here you can see the I minus. So we will go from 255 to 0, and the function will be same for this. And we are also giving a delay here, which is 20 milliseconds. So now we will upload this code to our Arduino. So we have uploaded the code to the Arduino. Now I will power it. So here you can see the brightness of the LED is increasing and decreasing, and the total time span is almost 5 seconds. Now we will give a look into the digital and analog input of Arduino. To visualize the digital and analog input, we need some kind of monitor. So here we are going to use serial monitor, which is integrated in the Arduino IDE software. Serial monitor is a type of tool which can be used for displaying, monitoring and debug purposes. So the data sent by the Arduino can be visualized in the serial monitor, and we can also send command from the serial monitor to the Arduino. Take a look in this digital input code. So first we have include the pin number, and here we are taking constant int variable, and the variable name is input pin, where we are storing our pin number, and in this experiment we are using the pin number 5. Next we have take a variable which data type is integer, and the variable name is reading. Now come to the void setup burst. Here you can see a new line which is serial.begin. So as we have said that we have to visualize the digital reading in the serial monitor, so we have to start the serial monitor. For that we have to write this serial.begin, this line. And here you can see in the parenthesis there is a number which is 9600. So serial communication, or this serial monitor, communicate through UART communication, and each and every UART communication has a baud rate. We are using this 9600 baud rate, but Arduino has several baud rates like 115200, 4800, 195200, many baud rates. So you can see the list of baud rate. The next line is known to you, that is declaring the pin mode. As in this experiment we are taking digital input, so we will declare our pin as input pin. So we are declaring the input pin mode. Now in the void loop, this reading is an integer variable, and this can store integer data. Now this digital read function, for taking digital input we have to write this function digital read, and in the parenthesis we have to give one argument. This is the pin number. So we are writing here input pin because we have stored the pin number in this input pin variable. So this digital read function returns 0 when the pin is connected to ground, and this function returns 1 when the pin is connected to VCC, or we can say to the 5 volt. So it will return 1 and 0, 1 or 0, and it will be stored into the reading variable. Then by using a command serial.println, we are printing the value in the serial monitor. Which value we are printing? The value of reading. So we can visualize the data 1 or 0 in the serial monitor. So this is the code for the digital input. Now we will upload it to the Arduino. So here we have the circuit of digital input. We just need a push button. One end of the push button is connected to pin D5, and another end is connected to plus 5 volt. Now let's connect this Arduino to the PC, and I have already uploaded the code to this Arduino board. So now let's see the digital input in the serial monitor. While doing the experiment of this digital input, you may have faced a problem, which is you are getting randomly 1 and 0 in the serial monitor without pressing the push button. So this problem is called floating point problem. So why this is happening? Because when you are not pressing the push button, your pin is connected to nowhere, not to the VCC or not to the ground. So your pin is in floating condition. For this reason, you are getting randomly 1 and 0 without pressing the switch or without giving any input to the pin. So to avoid this problem, we use a resistor connected in between the pin and the ground, and this configuration is called pull down configuration, and in this configuration switch is connected between the pin and the VCC. So when you press the push button, the pin is connected to VCC, so it will return 1, and when you are not pressing the switch, the pin is connected to the ground through a resistor, so you will get 0 reading. And I would prefer to use a 10 kilo ohm resistor, but you can use any resistor which value is greater than 1 kilo ohm. And there is another configuration which is called pull up configuration. In this configuration, the pin from where you are taking the digital reading, a resistor is connected in between the pin and VCC, and the switch is connected to the pin and the ground. And in this situation, you will get always 1 when you are not pressing the push button, and you will get 0 when you are pushing or pressing the push button. Now we will connect a 10 kilo ohm resistor in between the pin, which is D5 in our case, and to the ground. So this arrangement is pull down arrangement. Now I will plug the Arduino to the PC again. And now I will press this button, and you can see the serial monitor. When I am pressing this button, the reading is 1, and I am releasing the button, the reading is 0. So the problem is successfully removed. While doing the experiment of digital input, you may have noticed that although I am pressing the push button for once, you will see multiple ones in the serial monitor. This problem is called debounce effect. So why this is happening? Because a human hand can take from 200 to 400 milliseconds from pressing to releasing a push button. And on that time, our code takes the input multiple times, so you are visualizing the multiple one in the serial monitor. So to avoid this problem, we will put a delay after taking each input, and the delay will be of 200 to 400 milliseconds according to your choice. So now put the delay in the code and see the thing in action. For avoiding the debounce effect, we will put a delay. We are putting a delay of 300 milliseconds. Now we will upload this code and avoid the debounce effect. So now let's discuss about analog input. For taking analog input, we need an analog to digital converter, and our Arduino have a 10-bit analog to digital converter or ADC. So we can capture any type of analog signals from 0 to 5 volt in total 1024 steps, because 2 to the power 10 equals to 1024. So for doing this experiment, we need a Arduino, a potentiometer, the value of the potentiometer is 10 kilo ohm, and a breadboard and some jumper cables. So here is the circuit of our analog input. I am using a 10 kilo ohm preset as I don't have a breadboard friendly potentiometer, and one end of the preset is connected to ground, another end is connected to 5 volt, and the center pin is connected to A0 pin of the Arduino. This is the code for analog input. Here first we have declared the analog input pin, which is A0, because we can use only from A0 to A7 pin for taking analog inputs. And here we have taken a variable, integer variable, which name is reading. Now in the void setup part, we are only declaring the serial.begin function, but here we are not declaring the pin mode, because this A0 to A7 pin can only take analog inputs. For that reason, we don't have to declare the pin mode in case of analog inputs. Now in the void loop part, we are storing the reading of analog input into this reading variable. So for taking the analog input, we have this function analog read, and in the parentheses we have to give the pin number from which pin we are taking the analog input. And in the next line, we are printing the value of reading variable in which the analog read value is stored. So now we will upload this code and see this in action. Now I will connect this board to the PC and see the readings in the serial monitor. Now I am rotating the preset using a screwdriver and you can see the changes in the serial monitor. But the minimum and maximum value is in 0 and 1023. I hope you guys learned something from this video about Arduino's analog input-output, what is debounce effect, about the pull out and pull down arrangement. And if you guys love this video, so make sure you hit the like button and share this video with your friends and technical community. And if you have any doubt, put it in the comment. I will try to answer your doubt. And if you are new to this channel or seeing me for the first time, then consider subscribing and press the bell icon for notification about my video. And if you want to support our effort, then you can buy me a coffee. Link is given in the description below. And the most important thing, be creative.